everyone, in this video we're going to go through the vocabulary and kind of main topics for our next lesson, which kicks off with parallel lines, and it is chapter 3, kicking off chapter 3 in your book. All right, so parallel lines are two coplanar lines that never intersect. Arrows are used to indicate that the lines are parallel, so that just means that they go on forever. And then the symbolic notation for parallel lines is kind of looks like the number 11. Okay, so this symbolic notation states that line AB is parallel to line CD. Parallel planes are planes that never intersect. So here you've got plane J and plane K, and they will never intersect. And your symbolic notation, plane J is parallel to plane K. Skew lines are non-coplanar lines that never intersect. So they're lines that do not lie on the same plane and they never intersect. So for example, on the planes to the right, we've got line PS is skew with line VR. So those are not, line PS does not lie on the same plane as line VR, so they're non-coplanar, and they will never intersect, so they're skew. And then you can see also TW and UQ are skew, and PT and QR are also skew. So they're non-coplanar and never intersect, okay? But the difference between skew and parallel is that parallel lines are coplanar. And they're two coplanar lines that never intersect, okay? All right, so let's take a look at example 1. So name all segments that are parallel to AE. Well, you could see that AE is parallel to BF. AE is parallel to CG. And AE is parallel to DH. Okay. And two examples of parallel planes. Well, plane ABF is parallel to plane DD. There it is, CG. And plane ADH is parallel to plane BCG. Now to look at segments that are skew to GH. Skew to GH would be FB. Skew to GH would be EA. Also AD will be skew, and BC will be skew. So in the completed notes on Canvas, you can go ahead and take a look at example 2. I would actually try it on your own first, and then check your answers on with the notes on Canvas. All right, so next thing we're going to talk about is what a transversal is. So a transversal is a line that intersects two or more lines. So line T is intersecting, in this case, two lines, intersecting line L and M. So line T is a transversal. So let's take a look at the angles that are formed by a transversal and the names of those angles. So over on the left here, you have this picture of line L and line M. It's actually the same picture. Line L and line M being intersected by this transversal T. And then you've got some angles that are formed, all right, when that transversal intersects both of those lines. And those angles have names. So we've got corresponding angles on the same side of the transversal and in the same position. So 1 and 5, both on the left side and both on the top left corner. So those are corresponding. And 2 and 6 are corresponding angles. 4 and 8 are corresponding angles. 3 and 7. Alternate interior angles are non-adjacent and on opposite sides. So 4 and 6 are alternate interior, and 3 and 5 are alternate interior. And interior is this spot right here. So this is where your alternate interior angles are. So 4 and 6 and 3 and 5. This is the exterior outside here. And then your alternate exterior angles would be 1 and 7 and 2 and 8. So interior and then exterior, and alternate. So alternate interior, alternate exterior. Then we have consecutive same side, and consecutive same side interior. So we're interior and consecutive same side, that's 4 and 5, and then 3 and 6. So they're consecutive same side interior angles that are on the same side of the transversal. And then consecutive same side exterior, 1 and 8, 2 and 7. So if you need to hear that again, just rewind and go through that. But that is the basically terminology when we say, okay, who are corresponding angles 1 and 5 are, 2 and 6 are, etc. So taking a look at the angle relationships here, I'd like you to try this on your own, and then you can pause the video and just look up to check your answer. But I also want to take note of these nones. And let's look at that specific one right there. So angle 6 and angle 11. So angle 6 and angle 11. Well, since angle 6 and angle 11 are not being created by the same transversal, there is no relationship there. So what you're looking for when you're looking for the relationships is you're looking for the transversal and then the lines at the transversal intersects, and that's where you're looking at your interior, exterior corresponding, right? So top right corner, these would be corresponding angles 6 and 14 and so on and so forth. Look at this other none. We've got 4 and 13. Again, 4 and 13 are not being created by the same transversal. There's no relationship between them. So, you've got the answers right here. If you are new to this or need a little practice, pause the video, look down at your paper, try and answer. If you look up, see if you got it right. Just being able to identify the vocabulary, who is alternate interior, who is alternate exterior, consecutive interior, and so on and so forth. So why do we care about transversals? Why do we care about all those angle labelings that we just talked about? We care because there's a whole land of information between parallel lines and transversals. So if we go to the ones that we were just doing before, those lines that were being cut by the transversal, they weren't parallel. So you were just using that to identify, these are corresponding, these are alternate interior, etc. But specifically, when two parallel lines are cut by a transversal, things happen. Okay? When two parallel lines are cut by a transversal, those corresponding angles, they're always congruent. The alternate interior angles are always congruent. The alternate exterior angles are always congruent. Again, guys, this is only when parallel lines are cut by a transversal. Not any line, because that wouldn't even make sense. It didn't even make sense in the pictures before, but it does make sense when you're looking at parallel lines cut by a transversal. Consecutive same side interiors are supplementary, and consecutive same side exteriors are supplementary. And then we also know from our previous work with angles that vertical angles are always congruent, and angles that form a linear pair are supplementary. So let's take a look at what we've got here, okay? So here is here's the diagram. You've got two parallel lines cut by a transversal. You've got corresponding angles 1 and 5, 4 and 8, 2 and 6, 3 and 7. Those are all corresponding, therefore they're congruent. Alternate interior congruent, 4 and 6, 3 and 5. Alternate exterior are congruent, 1 and 7, 2 and 8. Okay, so 3 and 5. Those are alternate interior, and they're congruent. 1 and 8, those are consecutive, same side, and exterior. They're supplementary. 2 and 6, those are corresponding, right? Same position, and they're congruent. 1 and 7, those are, what are they? They are alternate and exterior, so they're also congruent. And there's the rest of the gamut here, but let's take a look specifically at 2 and 4. 2 and 4 are just straight up vertical angles. They're congruent. 5 and 6. 5 and 6 aren't any of the new words. They're just a linear pair, so they're supplementary. And there's the rest of them. So try example 2. Try example 2, pause the video, try example 2, and then you can look up momentarily and check your answer. So hopefully you paused the video and tried. So here you've got your answer, double check. If you have any questions about this example, please be ready to ask it in class. So last but not least, what I would like you to do now that we have kind of prepped you a bit on this is I want you to try these. Yes, the answers are right here, but you can pause the video and use it as an answer key. Look down and try these problems to make sure that you can fly at least a little bit solo. As you go through these, I want you to think about any questions that you have for me, because on Monday, when we meet, we're going to go through some more of these practice problems so that we can move on to proofs with parallel lines on Tuesday. Thanks for watching.